This video is designed to focus on the specifics of the mathematics item types of the Florida Standards Assessment, also known as the FSA. The presentation will share the background of the assessment design, as well as explore the different item types and the implications this assessment will have in the classroom. The information in this video is up to date as of September 1st, 2016. This quote, taken from the FSA Family Brochure, provides the basic background behind the development of the FSA. The Family Brochure is available on the FSA portal we will look at later in the video. The Florida Standards in Mathematics and English Language Arts were approved by the Florida State Board of Education in February 2014 and were fully implemented in grades K through 12 beginning in the 2014-2015 school year. All Florida schools will teach the Florida Standards, and the Florida Department of Education has contracted with the American Institutes for Research to develop and administer new statewide assessments. These assessments will provide parents, teachers, policymakers, and the general public with information regarding how well students are learning the Florida Standards. Also taken from the FSA Family Brochure, this quote advertises the fact that Florida is transitioning to a computer-based test, and through this testing format, technologically enhanced items can be included. These TEI are able to assess students in a way multiple choice was not able to. Note the highlight of the phrase higher order thinking skills. Thinking of our standards, this shows how the FSA will use rigorous items to assess not only the computational and procedural skills of students, but also the thinking and reasoning skills of students as well. This phrase and the following examples of items should be a key point for teachers and all stakeholders to apply when planning for instruction. Why should teachers and all stakeholders, such as administrators, parents, and students, be cognizant of this type of questioning? What implications should this have on instruction? Teachers should be aware that students will be assessed using question types that assess their higher order thinking skills and should include opportunities for students to display these skills during classroom instruction. Students should be asked to explain, justify, compare, and connect strategies, etc. Without having the opportunity to do this in the math classroom, students will not be prepared for the FSA's rigorous items. This chart shares the transition into the FSA. Note that beginning in the 2016-17 school year, grades 3, 4, and 5 will all assess mathematics using the computer-based platform. The FSA portal was developed by the Florida State Assessment Department. It provides resources to administrators, teachers, and parents. The portal is updated when the state has new information to share. Anyone wishing can also subscribe to the department's email list to receive updates. This can be done on the homepage. Included among resources on the FSA portal are practice tests or training tests. Caution should be had in how these practice tests are used. The training tests include items that may be used primarily as examples of the item types, not necessarily the content. The content level used in the examples may not fully match the standards, but can be used to give an idea of how certain item types will look. These tests are not intended to mirror or predict the actual FSA. The actual FSA will have 60 to 64 items spread over 2 days of testing. These training tests also do not include all of the grade level standards. The training tests should be used only to expose students to the types of items and allow them practice with the skills needed to navigate through the computer-based system. The acceptable response mechanisms are basically what types of response items a standard may be assessed with. A standard could be assessed using multiple types. The rest of the presentation will explore these item types. This 4th grade standard dealing with applying the area and perimeter formulas for rectangles could be assessed using 3 different item types. Here we see an example of the standard assessed using what is called an equation response. Students create an expression, equation, or value to answer the question. Next, we see the standard assessed through a graphing response. Students create a possible rectangle with the given perimeter. Finally, we see the standard assessed through a multi-select response. Students are asked to choose more than one rug with the given dimensions. This slide is a summary of the different types of technologically enhanced items available on the FSA. We will explore each type and how we are preparing students in the classroom to develop the skills needed to be successful with these types of items. Here we see an example of a multiple choice item. This type of item was used on the FCAT, but the depth of questioning may differ from past assessments. Multiple choice items will have 4 answer stems with 1 correct response. Here are 2 examples of multiple response items, or multi-select items. This item type is new to Florida state testing. In Hillsborough County, we have included these item types on unit tests to prepare students. Students may see between 5 to 8 different response stems to choose from. Students will choose 2 or more correct responses. In regards to multi-select items, will students have to select all of the correct responses to receive credit? The answer is yes. They must select all the correct and only the correct responses. So what might you see occurring in the classroom to prepare students for these types of items? The use of active thinking will help students in both multiple choice and multiple response item types. Active thinking involves students examining every response, determining why correct answers are indeed correct, and determining why distractors might have been used. This is not to look at how test writers are trying to trick students, but a valuable discussion can be had on how distractors are usually created with a purpose. The purpose is that distractors are often examples of popular misconceptions students may have. Active thinking may also help students to overcome the first answer fallacy within multi-select items. Many students have learned or been taught that once they find an answer that works, they can stop there. This may be the case with multiple choice, but not with multiple response. Here is an example of a student using active thinking to process the answer choices to a multiple choice item. Well, I know A is not correct because you should add 7 plus 7 first, not 7 times 7. B is not correct because you should add 7 plus 7 first, not 7 divided by 7. C is not correct because you would have to multiply first. Therefore, D is correct because you first add, then multiply left to right, then you divide. Here's an example of a student using active thinking to process the answer choices to a multi-select item. Select all the expressions that have the same value as 30 divided by 10. I know 30 divided by 10 is 3. So 1 times 3, that is 3. That must be correct. 10 divided by 30 is a fraction. That's 1/3. That's not the same as 3. 30 times 10, that's way more than 3. That's 300. That is not correct. 30 divided by 10 is 3, and 3 divided by 1 is 3, so that is also the same as 3. 30 divided by 2 divided by 5. I'm pretty sure that that is not 3. I don't even know how to do 30 divided by 2/5. And 30 divided by 2, then divided by 5. Well, I know 30 divided by 2 is 15. Then 15 divided by 5, that is 3. So that one is also correct. Another category of FSA item types are the gridded items. Gridded items will require students to use the tools on the screen to either plot points on a coordinate plane or to use points and lines to create shapes and figures. Here is an example of a gridded item. Students must create and draw on the screen the appropriate rectangles for the problem. They must then use their rectangles to answer a question as well. Technology is not always available to every student at all times in the classroom. We must look for other mediums in which to provide students the opportunity to develop the skills needed to respond to gridded item types. What other resources could be used in the classroom to develop these skills? Geoboards provide a concrete model for students to create shapes and figures. Students can then record what was done on the geoboard using dot grids, and eventually move into using gridded paper. Note also on this grid that one square section may not always use a single unit. A paper version of the FSA grid was provided to teachers for use in the classroom. Use of mediums such as these will help students to not only develop a conceptual understanding of the content, but also to build the skills needed to create figures on a computer screen. Think Central can be an opportunity for students to practice their gridding skills using technology. The tool does not provide questions, but could be used to solve questions from the classroom or homework using technology rather than pencil and paper. Here's a quick video of a student using the grid tool from iTools to represent this garden problem. Think Central can be an opportunity for students to practice their gridding skills using technology. The tool does not provide questions, but could be used to solve questions from the classroom or homework using technology rather than paper and pencil. Similar tools can be located at the Library of Virtual Manipulatives. Here is an example of a virtual geoboard. Another type of graphic response are graphing items. Students will create their own pictographs, line plots, and bar graphs. Here is an example of a third grade item where students use clues to create a pictograph. Why are students being asked to create their own graphs on the FSA? Look at the standard on the slide. This third grade standard begins with the word draw. The FSA assesses the content standards, which in most cases require students to create their own graphs. The FSA also assesses these standards for mathematical practice. Notice these SMPs that are aligned with this standard. Students should recognize graphs as a tool and use the tools appropriately. They should also use real-life applications in creating their graphs. For example, collecting measurements in their classroom of distances jumped and then creating a line plot. What implications does this have in the classroom? We must provide experiences for students to create their own graphs, not just look at pre-made graphs to solve problems. This is a page from a Go math book that requires students to create their own pictograph. The next type of graphic response items are the drag and drop responses. Students will do exactly as the title states. They will literally drag items on the screen and drop them into the appropriate place to solve the problem. Here, students drag digits and operation symbols to create the correct expressions. In this problem, students are asked to drag numbers to the boxes to complete the multiplication problem. In this third grade problem, students are dragging star stickers to make equal groups and then creating a division equation that represents those groups. And finally, we see where students could be asked to drag fractions to their correct location on the number line. How can students gain the experience of dragging and dropping items, numbers, and math symbols in the classroom? Well, one solution is to use drag and drop cards. Each student can have a laminated set of these cards to use in the classroom. The cards do not need to be used every day for every problem, but once in a while, students can generate their expressions, equations, or answers using the cards. Here's an example of a task students could easily do using pencil and paper, but could just as easily use drag and drop cards for. The student will organize stars and other objects into equal groups. Rather than writing the equation, students can use the cards to create the equation. Post-it notes can be used to practice the skills of hot text and drag and drop as well. Hot text items are an item type that requires students to type in a particular area of a problem. This can be modeled with index cards or post-it notes, and then place the cards or notes into the correct position. Open number lines are a great way to use this model. Students will be required to drag and drop using number lines in many instances on the FSA. Using open number lines in the classroom will help to develop the skills needed to complete these tasks. It is also a model that provides deeper thinking as called for by the standards. Writing the values on post-it notes or cards takes the drag and drop method one step further. This is a practice teachers are already embedding into classroom instruction. In open response items, students will need to type their explanations or justifications to a solution or strategy. Open response item types are necessary as we examine the wording of many of the standards. For example, in this fourth grade standard, we see the word explain. Students must be given the opportunity to explain their thinking with these types of standards. This is also another example of how the standards for mathematical practice are also included in the assessment. For example, SMP 3 calls for students to justify and examine other strategies. There are many existing problems and questions that require students to use explanations, such as this one. This first example is from an FSA item type. Note how open-ended the question stem can be. This higher order thinking question is a great way to assess student understanding, and similar type questions could be used to summarize learning in the classroom. The second example is taken directly from a Go Math book. Notice the use of the term describe. Though the FSA does not provide sample rubrics for scoring of these types of items, teachers may use classroom rubrics to help students to self-assess their response in the classroom. Teachers may also wish to utilize the keyboard to have students type their responses when accessible to computers. The final TEI category is the equation response. Equation response items will be included on the computer test versions of the FSA. Students will use the equation response field to generate expressions, equations, values, and any other combination of numbers and math symbols. Note the use of variables in the example item. In this item, the variable E and A are given. The variables will differ depending on the context. Other symbols will need to be discussed as well. The fraction, exponent, and parentheses action buttons must be selected first to allow students to add digits in those different formats. Teachers have been provided paper versions of the equation response field. These can be laminated and used with dry erase markers to allow students to create expressions, equations, values, etc. Looking at this example task from Go Math, notice the next portion of the task. Write the problem you need to solve. This type of task could easily be used on the FSA as an equation response. Students can use their equation response sheet to create the equation needed to solve this problem. They could even be asked to include a variable for the missing unknown. Much as with the drag and drop cards, the equation response sheet does not need to be used daily, but it should be used with enough frequency to let students become familiar with the values and symbols available on it to create their own expressions and equations. Rather than writing on paper, on occasion, the equation response sheet can be used instead. This table lists the number of items, number of sessions, type of test, and duration of tests for grades 3 through 5 in 2016, 2017, and beyond. The number of items is similar to the FCAT 2.0. However, students have been given 20 additional minutes of testing time. A conversion sheet will be provided to 4th and 5th graders when taking the FSA. The conversion sheet is also available as a pop-up window on their computerized versions of the test. These links were discussed during the presentation. Don't forget to view the parent videos available on YouTube by searching for our Math Smarts PD account. Though the FSA may look new, we hope this presentation has shown how students have already begun acquiring the skills needed to be successful on the assessment through their mathematics experiences in the classrooms of Hillsborough County Schools.